Find an equation of the tangent line to the curve y equals x times the square root of x that is parallel to the line y equals 6 plus 6x. Okay, so the first thing we want to do is we want to take a look at this function. So the function is given to be y equals x times the square root of x. This is the same thing as saying x times x to the 1/2. Okay, now remember that this exponent is 1, which is the same thing as 2 over 2. So this is the same thing as when you multiply the same base, you're going to add your exponents. So therefore, this function is x to the 3 over 2. Okay, so let's rewrite that. So we have x to the 3 over 2. Okay, now we're going to use this function y, which is equal to x to the 3/2. So now what we want to do is we want to find the derivative of this function. So we're going to find a derivative with respect to x of x to the 3/2. And so that's y prime. So y prime is going to equal, well, this is going to be 3 over 2 times x to the 3 over 2 minus 1, which is the same thing as 2 over 2. So we're going to see that the derivative is going to equal 3 over 2 times x to the 1/2. So therefore, there is our derivative function. Okay, now we need to determine, okay, what is the slope of the line that is parallel? So the slope is here, which is in step number 3, we're going to say the following. We're going to say that the slope, in this case, of the line y equals 6 plus 6x is 6. So the slope of any line that's parallel to it is also going to be 6. So what does that tell us? That tells us that y prime is going to equal 6. And what we're going to do is we're going to substitute it into the derivative function. So if we said that 3/2 x to the 1/2 is equal to y prime, we're going to place y prime to be 6. So we have 3 over 2 times x to the 1/2 is equal to 6, because we want to determine what is the value for x. Well, what we're going to do now is we're going to multiply both sides by 2. So we have 3x to the 1/2, and that's going to equal 6 times 2, which is 12. Now we're going to divide both sides by 3, and so therefore we're going to have x to the 1/2, which is equal to 4. Okay, so now if we want to solve for x, we're going to raise both sides to the second power, because x to the 1/2 to the second power is going to give us x, because 2 over 2 gives us an exponent of 1. And we know that 4 squared is going to equal 16. So now we determined that the value of x is going to equal 16. So we can say the following. We can say that this value of x is the x-coordinate of the point on the curve at which the slope is 6. So we can now determine what is the value of y by plugging it into the original function. Now remember that the original function is the following. We have y, which is equal to x times the square root of x. So we're going to plug in 16 into this function. So this is 16 times the square root of 16, which is the same thing as 16 times the square root of 16, which is 4. And that gives us 64. So what does that ultimately tell us? Well, in step number 6, we know that the point is going to be 1664 So we have our point, which is at 1664. And then we also know that the slope is equal to 6. So now we can use our point slope form to find that tangent line. And remember, the point slope form is y minus y1 equals m times x minus x1. So we have y minus 64, which is equal to the slope of 6 times x minus 16. Now let's solve for y. So we have y minus 64, which is equal to 6x minus 6 times 16 is 96. And then if we add 64 to both sides, then we get y, which is equal to 6x minus 32. And therefore, that's going to represent the equation, or the equation here of the tangent line that is parallel to that line. And you can see here that it has the same slope, and it would be parallel to that line.